In this video, we're going to take a look at how we use multiplication and division to solve one-step inequalities. So, traditionally, if I have 3x is going to be greater than or equal to 12, you would say that I would divide by 3, so that x is going to be greater than or equal to 4. Okay. In this case, you would be absolutely correct. X is going to be greater than or equal to 4. So we can test this. We can test out our solution to say, okay, let's suppose x is going to equal 5. You'll notice here that I, on purpose, pick a value of that is a solution here. That x is going to be greater than or equal to 4, so let's assume x is equal to 5. Let's plug it back into my original equation of 3 times x is equal to 12, except for instead of x, we're going to put times 5. Is 15 greater than or equal to 12? This answer checks. Where this becomes a little bit different and a little bit more complicated is supposing, let's say I had negative 3x is going to be greater than or equal to 12. When I go to divide, I'm going to divide by a negative 3 to solve, which will cancel these out. Since I am dividing by a negative number, what this also forces is a flip in the inequality sign, that I move from greater than or equal to less than or equal to, and it's going to be negative 4. Okay? This change in inequality sign comes as a result of dividing by this negative number. Since this changes the sign from positive to negative, I also need to flip the inequality. I can test my answer, test my solution. If x is less than or equal to negative 4, let's suppose x is going to equal negative 5, something smaller than negative 4. In this case, I'm going to have negative 3 times negative 5, or 15. Originally it was greater than or equal to 12. Is 15 greater than or equal to 12? Indeed it is. If I failed to flip my inequality sign, let's test something where x is going to be greater than or equal to negative 4 to see if it's a solution to the negative 3x is going to be greater than or equal to 12. Let's suppose x is equal to negative 3. It's larger than negative 4. What's negative 3 times negative 3? I would get positive 9. Is positive 9 greater than or equal to 12? So this would be a no. What you will notice, if I go through another example, if I gave you 3x is less than negative 12, you'll notice I'm dividing by a positive 3, so I get x is less than negative 4. This is correct, because even though this is negative, I am not multiplying or dividing by a negative. So what was negative remains negative. So I do not need to switch that inequality. Okay. If, however, it was negative 3x is less than negative 12, as soon as I divide by a negative 3, I need to switch that inequality, turn that inequality from being a less than to a greater than. The negative 3's will cancel out. I'll get x is going to be greater than 4, which is my solution. So the key part of this is you switch or flip your inequality when you are multiplying or dividing by a negative number in the solving process. So it's not a matter of what it is originally, but as soon as you try to get the sides, get to your solution, as soon as I divide both sides by the negative, I switch the inequality. Hopefully this has helped a little bit.